Good morning and welcome to all of you to our channel Next Generation Engineering. Here we talk about design engineering and project management for next generation engineers. This is a part of our smart city series. Today we are going to talk about smart cities for more livable future. Cities are home to more than half of the world's population and they are expected to add another 2.5 billion new residents by 2050. They face increasing environmental pressure and infrastructure needs and growing demands from residents to deliver a better quality of life and to do at a sustainable cost. Smart technologies can help cities meet these challenges and they are already enabling the next wave of public investment. It all starts with data. Cities in all their complexity and scope generate portion of it. Finding the insights in all that data helps municipal governments respond to fluid situations, allocate resources wisely, and plan for the future. Furthermore, putting real-time information into the hands of individuals and companies empower them to make better decisions and play a more active role in shaping the city's overall performance. As cities get smarter, they become more livable and more responsive. And today, we are seeing only a glimpse of what technology could eventually do in the urban environment. Smart cities add digital intelligence to existing urban systems, making it possible to do more with less. Connected applications put real-time, transparent information into the hands of users to help them make better choices. These tools can save lives, prevent crime, and reduce disease burden. They can save time, reduce waste, and even help boost social connectedness. When cities function more efficiently, they also become more productive places to do business. More or less, a smart cities layers can be divided into security, healthcare, mobility, energy, water, waste, economic development and housing, energy management and community. These are the basic layers of a smart city. We will discuss mobility or transportation, energy, water and waste management as they are technology domain of a smart city. So the mobility domain or transportation of a smart city uh, are comprised of real-time public transformation, digital public transit payment, autonomous vehicles, predictive maintenance or transportation infrastructure, intelligent traffic signals, congestion pricing, demand-based microtransit, smart parking. Energy management in a smart city domain comprising of building automation system, home energy automation systems, home energy consumption tracking, smart street lights, dynamic electricity pricing, distribution, autonomous systems. Water management in a smart city are comprised of water consumption tracking, leakage detection and control, smart irrigation, water quality monitoring. So we have seen there the major domains of the smart cities and the technological domains of the smart city and the salient features of those technological domains so far. Another domain of that is another important domain of smart city because we are going to generate ton of waste when there are going to be more and more people living in the city. So obviously waste generation will be more and waste management would be a very important aspect of a smart city. So waste management domain in a smart city comprises of digital tracking and payment of waste disposal, optimization of waste collection routes. So here you can see the basic relationship between the job creation and various aspects of smart cities and how smart city will impact various important factors, socio-technical or socio-political factors of our life. So for an example, the disease burden will be reduced to 8 to 15%. The commute time will be reduced to 15 to 20%. Time spent interacting with healthcare and government will be reduced to 45 to 65%. So that would add time and convenience to any individual's life. Safety. The fatalities will be reduced by 8 to 10%. Obviously, when all the cars and other things will be connected to a single source or single server and every signal will be controlled by an automation or an algorithm, then the chances of accidents will be less, so fatalities will come down. Crime incidents will be less than 30 to 40%. Of course, when predictivity matters, uh, your emergency response time will be 20 to 35% less because communication will be much more faster, and your with the predictive timeline and the rapid communication systems, that emergency response team will reach 20 to 35% faster than they are reaching now. Cost of living will be reduced to 1 to 3%. Job, the formal employment will be rising to 1 to 3% in a smart city. But this is, please note, this is formal employment. There will be many more jobs will be created through various startups and other business factors, which will help any individual's life, and they will create impact to create more and more smart cities and for livable futures. Social connectiveness and civic participants will be increased by 15 to 25%. So these are the benefits, and this is how the smart cities is going to deliver a more livable future. With this percentage are more or less the predictive data so far, but this will be very likely that these things will be occurring very soon, because today, even 10 to 15 years back, the communication today we are having, like having meeting over Zoom or WhatsApp or all this kind of that time pager was a very prestigious thing, having a pager. Now anybody can send message across anywhere in the world. So these things are not for a very far future, but this smart city and its various aspects are going to occur in very near future, that we need to remember, and accordingly we need to prepare ourselves with technology and all other aspects, and we need to upskill ourselves accordingly to cope up with the demand of job in future generation. So sustainability and smart city has a very good correlation. As urbanization, industrialization, and consumption grow, environmental pressures multiply. While technology is only one option for addressing these issues, it can be a powerful one. Overall, our analysis finds that deploying a range of applications to the best responsible extent could cut emission by 10 to 15%, lower water consumption by 20 to 30%, and it can reduce the volume of solid waste per capita by 10 to 20%. That's what we discussed in our previous slide. Smart city can help to reduce greenhouse gas emission too. In a city where structures are major source of emission, building automation system can lower emission by just under 3% if adopted in most commercial buildings, and by an additional 3% if adopted in most homes. Another application with significant potential, dynamic electricity pricing, which allows utilities to charge more when demand peaks. By reducing consumption and shifting the load of peak periods, it reduces the power sector's use of backup peak plants that produce more emissions. E-hailing and demand-based micro-transit could significantly reduce emission if fuel-efficient fleets offset more polluting alternatives. Intelligent traffic signals, congestion pricing, and other mobility applications also cut emission from traffic. Air quality. Some of the energy saving and mobility applications described above could improve air quality as a secondary benefit. To tackle this issue more directly, cities can install air quality sensors. They do not automatically address the cause of pollution, but they can identify the source and provide the basis of further action. Beijing reduced deadly airborne pollutants by roughly 20% in less than a year by closely tracking the sources of pollution and regulating traffic and construction accordingly. Sharing real-time air quality information with the public via smartphone app enable individuals to take protective measures, potentially reducing negative health effects by 3 to 15%, depending on current pollution levels. Here, I would like to mention one thing. This data, Beijing reduced deadly airborne pollutants by roughly 20%. This research was done prior to COVID era. That is somewhere back in 2019, early 2019 or late 2018. So please don't bring any kind of confusion here. This data is old, and that the outbreak of COVID is unfortunate, is not linked to this present video or this kind of slides. Please do remember that. Water conservation. Water consumption tracking, which pairs advanced metering with digital feedback message, can nudge people towards conservation. Here we would like to tell a few words about nudge. Nudge is a part of behavioral economics. We would like to, or would love to make videos about nudge in near future. So please, please put your comments in comment section if you want to see a video about nudge in near future from our end. so it can nudge people towards conservation. Just coming back to nudge is kind of thing that it's a procedure where you are someone is not forcing or someone is not having a mandate to do something, but still they are going to do it with some kind of motivation or some kind of inspiration. So that is called nudge, very shortly. So definitely we are going to have a video about nudge. It's a part of behavioral economics, which is very interesting subject, and it's linked with engineering and future. And it's I won't say better, but it's different from our traditional economics, which today we are following. So behavioral economics can change a lot of things. So nudge is one of this part. So coming back to the topic, it could water consumption, and this nudge could reduce consumption by 15% in a higher income city where residential water usage is high. Although its effectiveness depends on whether it is paired with a pricing strategy. In many parts of the developing world, the biggest source of water waste is leakage from pipes. Deploying sensors and analytics can cut those losses by up to 25%. Solid waste reduction. As low-tech recycling programs reach the limits of what they can do, technology could further reduce the volume of uncycled solid waste. Digital tracking and payment for waste disposal, for instance, charges users for exactly for the amount and type of trash they throw away. But this type of application should be considered alongside other policy initiatives, particularly in developing economics where household budgets are tight and a great deal of informal recycling already takes place. Thank you for watching this video. Please check our next video, and if you like our videos, please do like it, share it, and subscribe to our channel. That would be a great help and encouragement for us. Thank you. See you in your next video.